Master, members of the livery, ladies and gentlemen, good evening. I'm hugely honoured and frankly privileged, very privileged to make this presentation. This is intended to be a light-hearted review of some of the trials and tribulations and frankly the fun I've encountered on just a few projects in developing countries. I'm not going to read the slides, I'm going to talk around them, so you'll have to multitask this evening, and I just hope that what I say and what I've written roughly correlate. So we've got to understand that construction, basic construction in developing countries has evolved over thousands of years. And a lot of what they do is very good. It may be limited by the plant they've got and the technology they've got, but they use that to the best of their abilities. Health and safety, about which we'll talk more in a minute, can be pretty nominal. And quite a lot of their practices, as this slide shows, involve conditions that the RSPCA would not approve of. The game changes when the infrastructure that developing countries need has to be built, because by and large those projects are an order of magnitude or several orders of magnitude bigger than the local guys can manage on their own. And it's the integration of foreign design and contracting with the local workforce, which I've had quite a lot of experience of over the last 30 years and which I found continually challenging and fascinating. You'll probably have seen pictures like this, particularly those in civil engineering, which go around on emails on YouTube, and this won't be showing you very much with which you're not familiar. The guy on the left is stacking bricks on his head, far, far above where his hands can reach, and he's throwing the bricks up to make a balanced pile on his head. What this slide doesn't show is that he then walked across a 6-inch wide plank about 15 feet above water and then mud to get to the land without a care in the world, and incredibly well, he didn't fall off. That's what matters for him anyway. The guys on the concrete pumps in Mali, it's backbreaking work, but they can shift an incredible amount of concrete up to the second floor of the building, again with complete safety, but absolutely exhausting because simply they'd have no other way of getting the stuff up there. The pile driving in Pakistan on the right-hand side is simply 5 guys bouncing on a scaffold board in unison to drive the pile. They probably know that there is a load-bearing stratum 2.5, 3 meters below the ground, and it is on that their building will sit. No safety, no hard hats. You can't legislate for things like that. And the big problem we have is when we then try and send our own staff into conditions like this. You cannot expect a local firm, whether they be pile driving for a building or building a big bridge, necessarily to change their way of working completely to suit the way that foreigners would hope. Language is obviously a major problem, but essentially it's an inbuilt culture, and the projects don't have the money to enable the safety steps to be taken. And life is cheap. You know, people die. It doesn't cost anything like as much as it would in London or New York. So we then move on to start looking at some specific things. I hope this gives you an indication as to the way the game has moved on in the last 70 years. The 22RB on the left-hand side of this picture, of this slide, was the staple construction contract crane in the 1950s and 60s, and you still get some of them working away in odd parts of the empire. I came across one in the BVI about 18 years ago, quite happily, polished beautifully and working immaculately. And you probably had dinky toys of a crane like this when you were little, and yet it looks now like a dinky toy compared with the monster on the right. And although that's an exceptional monster, there are plenty of others of like similar capacity. And when you see, therefore, what bits of kit like that can do to enhance construction and speed things up and change the game, then it makes one realize that the whole form of construction, particularly for big projects, is completely different from that of the generation before us. But the workforce on the ground hasn't changed. They're still essentially, more often not, farmers. They're much better at putting a goat's milk into a bucket than they are putting a high-strength bolt into a hole and tightening it up. And that is That is the challenge. We'll start off on the northern side of the Gulf, southern coast of Iran. Dubai's on the other side of the ditch. And this was intended to be, well, it was building a jetty out into the Gulf to enable the berthing of very large ore-carrying ships. It had to go out 1,800 meters to get to deep enough water. On top of the jetty was going to be placed various conveyor belts, which would bring the ore from the ship to an ore smelter that was to be built on dry land right here. The jetty was built from 30-meter long precast, pre-stressed beams, 3 of them to a span, and they were hollow, so they had no end diaphragms, and the beams were joined by gaskets over the crossheads. So the beams could also bring back water, fresh water, not salty water, cool water, that would supply a power station that was to be built alongside the smelter. The contractor was Hyundai, and they'd actually had the contract for about 13 years before the funding became available to start the work on site. We were awarded the contract simply because of a non-standing relationship with Hyundai. So this was designed in Leafy, Surrey, and built in Ripley, Derbyshire, by sadly now defunct Butley Engineering. It was intended to be as simple as is possible, because we knew that if anything broke, the chances of getting it repaired or replaced was pretty minimal, and the program was reasonably tight. The function of the beast was simply as you can probably see there are 2 cranes. Both of them were using pull cylinders on gimbals rather than winches, because we felt that was the most fail-safe form of lifting. A precast concrete beam would arrive at the left-hand end, but at the rear of the gantry, would be picked up off its bogie by the front crane, which would then trundle off towards the central pier. When the rear end of the beam arrived at the back end of the gantry, it would be picked up by the rear crane, and the whole thing would trundle forward into the front span before being lowered to get the beam below the main gantry. The steel trusses slid sideways and put down on its bearings. The operation would then be repeated for the beam on the other side, and the span completed by putting a 3rd beam in the middle. The program was such that it was supposed to place 3 beams in a span in a day, and the gantry would then launch itself the next day. It was completely self-contained, needed no external devices to push it or lift it. The trusses were built up in their completeness in Derbyshire because we wanted to minimize the amount of work that was done on site. We had no idea of what the labor force was going to be. It turned out that it was Chinese, largely for cheapness, and they really weren't much use to us, or the Koreans, and Iranian, which was a contractual requirement. Some of the Iranians were extremely well educated and actually caused some of the difficult interactions with the Koreans, because actually they spoke better English than the Koreans did. The Koreans treated us perfectly, absolute gentlemen, but they were quite tough on the Iranians, possibly because of that. And they were particularly tough on some of the ladies in the site office. So what could possibly go wrong? Well, I'll start to tell you that. The first was that getting to the site was tricky. The first time we went to the site, we went through Tehran, and I think crossing the road, the main street in Tehran in the dark, is probably the most scary thing I've ever done. We keep on telling the site, when we send site staff out to sites like this, we say, don't do anything with which you feel uncomfortable. Well, I felt distinctly uncomfortable crossing the road in pitch darkness and traffic flying everywhere. We flew down to Bandar Abbas at the beginning of July, and it was incredibly hot. The queue for immigration was snaking across the tarmac, and we were more than just a little bit relieved when a chap came out of immigration and said he would help us fill in the immigration forms, which was lucky because they had to be done in Arabic, and I can't even speak Arabic, let alone write it. So he did that for us, and then announced proudly that his eldest son had a collection of paper money and he wanted to extend this collection. So we offered him paper money, but he decided he didn't like green notes and blue notes. He preferred red notes and brown notes. So that set the tone. We then got to the site and found that the Koreans were nothing like as far advanced as they should have been. But again, it comes down to a cultural problem. Korean sites are very much controlled from the site, but they are monitored by their Seoul head office. And they couldn't afford to tell the Seoul head office that things weren't going particularly well. So they didn't tell them at all. So we turned up a little bit early. And instead of having 6 weeks on the site, which would have been good for all of us to keep us away for beer for 6 weeks, we had 3 weeks there and then went home for about a couple of months and then finished off the job later. The project manager, the Koreans, well, as I say, extremely welcoming. And the project manager made it abundantly clear that beyond the site fence, which was quite prominent, was Iran. And inside the site fence was definitely Korea. And we were welcome to as much beer as we wanted because they were getting shipped over from Dubai in a rib once a week. So they had a positive can-do attitude. They didn't understand that things could go wrong. And therefore, and quite a lot of the time when things could have gone wrong, they actually didn't. The language was, again, a potential problem, again, the relationship between the Koreans, the Iranians, and us. They had a very good idea to turn my operation manual, which was written in English, into Korean, because they were going to use Korean crane drivers to operate the cranes. Good idea. And they had a very good idea as well, which was to take one of the junior engineers and to turn my manual into Korean, and then to take another junior engineer to take the Korean version and turn it back into English. In fact, it was such a good idea, I wish I'd thought of it myself. The translation I checked over fine until we got to the water sheep, and that caused a bit of a problem. What is a water sheep? And going back, it rapidly turned out that what had been lost in translation was a hydraulic ram. We have found on this job and various others, particularly in Korea, that the junior staff can be thrust into positions of seniority far above their normal station, bearing in mind that Korean contractors are fiercely hierarchical. And there was a famous case on an aircraft hangar in Seoul, where I was approached by one of the junior engineers, who was a lovely guy, not particularly bright, but his English was good. And he knew that I was fed up with being told incorrect things. There's a tremendous temptation for people to tell you either what you should hear or what they think you want to hear, as opposed to the truth. And I'd already given this chap, Mr. Wee, a bit of a hard time because I just wanted to know what was going on. I didn't mind if it was bad news, but his approach this morning, and this was a revelation this morning. And he said, Mr. Steve, what I'm going to tell you is what I've been told to tell you, and it's a lie. But don't get angry about it, because when I finish lying to you, I'll tell you the truth. What else could go wrong? Well, the next thing that went wrong was that the Bandar Abbas, which was the nearest port to the site, was closed. So the kit got delivered to Bandar Khomeini, which was about 500 miles up the road, was transshipped and came the rest of the journey by road. There was a bit of damage to the steel, but nothing, it was all fairly robust stuff and nothing there that couldn't be put right fairly easily. But on the way, we lost some bolts. And they were the bolts that joined the hydraulic motors to the gearboxes. And being 14 millimeters diameter and it's 300 millimeters long, are not the sort of things you can go and pick up from Halfords, even if there was a Halfords in Bandar Abbas. And without these, we were in a bit of a problem, but somebody had the bright idea to go down to the local souk. And fortunately, there was our bag of bolts. So we bought our own bolts back again, and that was fine. The next problem was that the Koreans had designed the shutters for these beams themselves. And you can see in the background of this photo there where they're stacked. The result of which is that the shutters were accepting far, far more concrete than they should have done. And therefore, they were considerably heavier, like about 10, 15% heavier than they should have been. It made the hydraulics struggle a bit. But that hydraulics are quite good at increasing their capacity. And it goes to demonstrate, and the structure didn't suffer. It goes to demonstrate what we've always said with machines like that, which is that a 10% overstress is nothing like as serious to the contractor on site as a 10 millimeter interference fit when things don't go right. An example of the problems that we had with, particularly with the Iranians, there was one not too bright laborer caught one afternoon and we were trying to remove some shims from underneath the beam, and it was almost clear, but not quite. And he was being yelled at by the Korean charge hand to say, hammer, hammer, hammer. And he couldn't see the hammer. It was somebody else was standing between him and the hammer. So in desperation, he found the nearest thing he could to a hammer, which regrettably was a theodolite. By the time we'd finished, got the packs out, this theodolite may have started a career as a hammer, but it certainly finished its career as a theodolite. And that was the way the job went on. In the end, they managed to place 2 spans of beams in one day and do a launch. So the machine once they got going, the machine was incredibly efficient, and it finished its gantry, building its jetty out into the Gulf, quite well ahead of program. Where sadly it stands to this day as a testament to, again, a problem of working in developing countries, because the funds that had been allocated towards both the steel plant and the power plant had been allocated to other things. And to the best of my knowledge, it still acts as a useful mooring for ships, but not much more than that. So we then go to somewhere which is less developed than Iran, which is Bangladesh. There's no rock in Bangladesh. So again, the contractor was Hyundai. They had to bring rock down from the Himalayas when the river was in spate, but actually these boats would float in a damp field. They didn't draw very much. What this picture, the top picture, doesn't show is that there will be 1 or 2 other guys in that boat bailing constantly. They leaked pretty badly. They would then be run ashore on the sand, the silt, and then an army of Bangladeshis would pick the rocks out of the boat and carry them up to the batching plant. And they would carry about 5 tons of rock each for about $1 a day. They were actually cheap. It was cheaper for the Koreans, and they had to do this anyway for contractual reasons, but it was cheaper to pay them $1 a day than it was to buy the diesel that would have been used for the bulldozers, particularly bearing in mind that the diesel that came into Bangladesh typically was diluted by 15 or 20% with water. Now, the diggers could probably have lived with that, but it did cause us a difficulty because the power packs on the gantry didn't develop the full power, and we had to get proper unadulterated diesel in to make that work. The machine was again designed in Leafy, Surrey, built in Ripley, Derbyshire. This time, though, it went out to site in much smaller pieces because the volume to put on a ship would have been enormous. And so we were teaching the local guys not to weld, but to do up friction grip bolts, to get the geometry right. And they were incredibly fast workers, fast learners, bearing in mind, as I say, their principal expertise was with goats and cattle. And the thing went together remarkably easily and quickly. At the time, this was one of the 2 largest bridge building gantries in the world, the other one being that was used by Lang GTM on Second 7. And again, our principal reasons were to make it simple. The principal philosophy that we have always used in projects like this is there are certain things difficult that you have to do, like the stuff on the right-hand side of this slide, which is the match casting, and that is a complicated thing by first world standards, let alone by third world standards. So that is something which the locals would have a hand in terms of placing rebar or pouring concrete, but in terms of geometry and setting the whole thing up, that was done by the foreigners, not us initially, but then the Koreans, and we stayed with the Koreans until they were good at it. And of course, being Koreans, they then became very good at it. And then it became repetitive. Now, you could rightfully say, well, what's the difference between that and a European site? And the answer is not a lot, really. It's just perhaps more important when you've got half the workforce, who are farmers. This time, because we had properly designed chapters, the segments turned out to be fine. They were the weight they should have been, and the project went pretty well. There was a difficulty with the pre-casting of the segments in that the design of having inclined webs and a variable depth of section meant that pretty well every segment that they made was different in terms of bottom flange width. Second Seven didn't suffer from that problem. And they never really achieved the production rate from the casting yard that they had hoped for or intended. But the gantry would still worked well. It erected all the segments it could be fed. The charge hands very quickly realized that they had to do this, work the operation in the sequence as defined, because frankly, otherwise the machine would fall over. And if this lot fell in the Jamuna River, which is, you probably know, a tributary of the Ganges, and it comes and goes all over the place, then something will go badly wrong, and the project will be stopped, not for months, but for years. I should say that although the bridge was expensive, it was not as expensive as the river training works, because being a braided river, the Jamuna can move around in its valley, and it would have been very frustrating to build 5 kilometers of bridge to find the following season that the river was no longer underneath it. So the river training works were a bigger part of the contract than the bridge. And actually the foundations for the bridge were a bigger part of the contract than the deck. The first time we started the launch, we had a briefing session for the Koreans and some of the senior Bangladeshis. And they went off out to site and they started, and it's strange because we went through the door and they seemed to forget everything they'd been told and think people were flying in all different directions. So we brought them back in again, went through it all over again. And this time it went well. And they began to get great satisfaction from seeing things fit together at the allotted time and that it all fitted together. And all of a sudden, magically, and we've had this with machinery like this all over the world, instead of being Steve's or Tony G's gantry, it becomes their gantry, and productivity goes up by 30% because they've got ownership of it. The job was finished just about on program. The gantry worked without a hitch. I was not on site for the later parts, but I'm told by the people who were that the teamwork between the Koreans and the Bangladeshis was immaculate. It wasn't just there for carrying vehicles, it carried a railway track and it carries a lot of oxen. It carries a water pipe, which there was a bit of a problem with because it fell off. The one thing the Koreans designed it, they designed it for the pipe, not for the water that went in it, which was a disappointment. And power lines. And the World Bank and the ADB, who funded the bridge, regarded it as being much more of an infrastructure a social project than an infrastructure project. We found the same thing on bridges crossing, say, the Mekong down in the Delta, southern South Vietnam, where it means that villages can talk to each other more. It means that the farmers can get better quality, higher priced goods to market, particularly those on the Mekong, which they can then get up to Ho Chi Minh easily and quickly by truck. And consequently, they earn more. In terms of Khao Lan, which was the bridge on the Mekong, it had a surprise advantage in that it reduced the spread of AIDS, in that the lorry drivers didn't have to wait on the riverbank doing what lorry drivers do, waiting for the ferry. They could just drive straight to market. So that was a hidden benefit, if you like. More remote still. This was a project promulgated by a gentleman called Mr. Batulga, who had already funded the building of the model of Genghis on his horse, which is on the steppes well to the east of Ulaanbaatar. It's in the Guinness Book of Records as being the largest sculpture of an animal. It is immensely popular. You climb up through the back legs of the horse and go through its body, and you eventually climb up to a viewing platform over the steps on top of the horse's head. And it is quite a remarkable structure. Mr. Batulga eventually became Prime Minister of Mongolia, being a man of considerable wealth in that he controls the meat industry in the country. And I met him in a bar in Ulaanbaatar years before this, and he then decided he was going to come up with this Grand Maitreya project. It was, when we started this, in the middle of absolutely nowhere. as I say, as the slide shows, 50 clicks south of UB. Although actually now the new airport, the new UB airport, is relatively close, with about 10 kilometers off the site. It is in an unbelievable valley. As the slide says, that it's not grass, it's sweet smelling herbs. And there's nothing for miles around except now the airport. For reasons I don't understand, the number 108 has significance for Buddhists. And the stupa itself is 108 meters tall. And the two hills behind it are at the same height. The Buddha will be the tallest Buddha. In fact, is actually now the tallest Buddha on earth, because it is actually now complete, as that slide shows. This project was different for us because we were never going to have much in the way of helping them to build the thing on site. The construction of the project was not that difficult. There were certain complications in that they wanted to get the Buddha built as quickly as possible, because that was going to bring the visitors in and would raise funds. And they couldn't do that. We demonstrated that they couldn't have the full Buddha without being propped at about waist level. So they had to do things in a sequence. But essentially, we designed the thing. It had already been designed once by a Chinese company, which was unbelievably inefficient. They must have been on absolute minimum fee, or that not having any interest at all in structural efficiency. But we were able to, we knew UB well enough to know the technology that they could employ there. They obviously knew structural steelwork, they knew concrete metal deck, they could even post-tension concrete if it was necessary. They have post-tension concrete bridges in Mongolia. They also have an extremely short building season, because they can't really, it's too cold to build outside from about April to October. So doing as much work in preparation as possible is really important. So the thing was designed to be built easily using their technology and without assistance from us. And indeed, that is what they've done. It will be a magnificent structure when it's finished. As you can see, it sticks out a very long way. The Buddha was cast by the same company as made Genghis and his horse, and they did a simply fantastic job of it. And I would recommend it if you happen to be passing, which I have to say is unlikely. The project eventually ran out of money because they were hoping for funding from rich Chinese. But sadly, China fell out with the Dalai Lama, and the Dalai Lama had blessed this project. And so funding stopped for quite a long while. It's now going again. Finally, you'll be glad to know, Peter, that there are other ways of building things in developing countries. The Civils created REDAR, the Register of Engineers for Disaster Relief, which is a fairly self-explanatory title. And many companies, not just Tony G, but I know Sir Michael has this project dear to his heart as well, donate money. It's actually quite a lot harder to donate people, because actually the people who are needed on the ground tend to be not the junior staff, but the more senior staff who've got wives, mortgages and breweries to upkeep at home, and are also probably the head of a design. REDAR tends to be a funding exercise rather than a doing exercise. But the alternative is Bridges to Prosperity, which I believe is of American origin. And I have to say the firm has taken this on since I retired. They take junior staff to wild places, in this case, Rwanda. The volunteers came from us and another UK contractor, Knights Brown, and they built a bridge. This river had killed children while trying to cross it during the previous flooding season. They designed the temporary works, they designed the construction engineering, the safety parts were reasonably good. And the bridge was intended to carry a cow, but it obviously carries a great deal more than that. And although it does considerable benefit to the local community, I think actually the guys who went to site, or guys and girls who went to site, probably came away with greater benefit from it than even the people who use it now.